Dear students, welcome to the video lecture session on power generation and economics. As our discussion is going under module 3, nuclear power stations. Okay. Today I am discussing the nuclear reactor classification. Okay. Classification of reactors. Nuclear reactors may be classified on the following basis. Okay. The basis depends on the neutron energy. Okay, thermal reactors, fast reactors, on the basis of fuel used, either it is natural or enriched uranium, on the basis of moderator used, graphite reactors, beryllium, water reactors. Fourth one is on the basis of coolant used, water cooled reactors, gas cooled reactor, liquid metal cooled reactor, organic liquid cooled reactors. On the basis of type of core used, homogeneous reactors and heterogeneous reactors. Okay. Let us begin with the first one, boiling water reactor. Okay. Boiling water reactor, in this reactor the fuel is used is enriched uranium, water is used as both the moderator and coolant. Okay, last class I have explained what is the moderator. I hope remember. What is the use? The moderator use is, the purpose of moderator is in the reactor core is to moderate or reduce the neutron speeds to a value that increases the probability of fission occurring. Okay, due to the fission occurring, that it will be reduces the neutron speed. Things moderator. Okay, clearly. Okay, it is made up of graphite, so it will be reduces the neutron speed. Okay. Now this in boiling water reactor, what they are using the as a moderator. In this reactor fuel used is the enriched uranium, water is used as both moderator and coolant. I repeat here, the water is used as a both. Okay, both in the sense it will be acts as a moderator and coolant. Coolant means what? Coolant is nothing but the coolant gives up heat to the heat exchanger, which utilizes in the rise the steam. Okay, or else other words it will be carries the heat. Okay, coolant, what it will be gives, it will be gives the taking the heat from the reactor, in other words, and afterwards it will be giving, if any last class I have discussed the heat exchanger is there it will be given. Okay, but in this case I will show you what it is there. Let us have first this how it is there. The coolant rod, just a moment. Okay, so sorry, here control rod. As already everything I explained in the last class, just I will discuss about the what is here boiling water reactor. Okay, control rod, then this is a core, reactor core. Here the water they are feeding. Okay, here itself the water it will be get heated up, and the steam is taken outside. Okay, one more point I have mentioned here, that the water is used as both. Water is used as both. Okay, both as moderator and coolant. Okay, it will be slow down the process also, as well as the heat it will be carries. Okay, this is the boiling water reactor. Okay. Morley what figure is no here not there anyhow. Okay. And there are few points we'll discuss here. Okay. In this case, the steam is generated in the reactor itself. Okay, as already I discussed here, the steam is generated inside the reactor itself. Feed water enters the reactor tank at the bottom. The feed water it will be enters bottom of the tank, okay, reactor tank, and takes up the heat generated due to the fission of fuel and gets converted into steam. Steam leaves the reactor at the top and flows into the turbines. From here it will be goes to the turbine. Uranium fuel elements are arranged in a particular, let's say, form inside the pressure vessel containing water. Here they are placing the uranium fuel. Okay. Feed water passed through the fuel elements. Water it will passes through the fuel elements in the core as coolant and also as moderator. Okay, what it is? The last sentence I repeat. Feed water passes through the fuel elements in the core as coolant and also as moderator. Okay. Next, the advantages. Heat exchanger circuit is eliminated, and as a result there is a reduction in cost and gain in thermal efficiency. In this BWR, boiling water reactor, BWR, what it is there? There is no heat exchange. Heat exchange means after taking the steam, there will be a one exchange. There it will be heat, it will be exchange, and it will be connected to the turbine next stage. I will discuss in the next one more. There it will be clear. Just you have to remember here that there is no heat exchanger. Okay, I repeat here in this BWR, no heat exchanger. This is another one circuit it is there, we can say that it is eliminated here. Hence, what it will be happens? What it will be happens? The cost will be reduced. Okay, comparison to the PWR. PWR one I will explain later. Okay, pressurized water reactor it is. PWR means okay. Here what it will be happens? Then there will be a heat exchanger circuit is eliminated, hence the cost will be less. Okay. So what it will achieve here? The 30% of thermal efficiency will be more as compared to the PWR. Okay. Second one is, as water is allowed to boil inside the reactor, the pressure inside the reactor vessel is considerably lower than in the case of PWR. Okay. As a result, reactor vessel can be made much lighter, reducing the cost considerable. Again, due to this, the cost will be less. The BWR cycle more efficient than the PWR. Okay, pressurized water reactor. Okay. Cycle, since for a given containment to pressure, the outlet temperature of the steam is appreciably higher in BWR. Okay, so the temperature will be appreciably higher in the BWR. Okay, the metal surface temperature is lower than in the case of PWR, since boiling of water is inside the reactor. Here in the pressurized water reactor, boiling of water inside the reactor, as I shown, right? So the what it will be there, the surface temperature is lower than. Fifth advantage is BWR is more stable than a PWR. In fact, BWR is commonly known as a self-controlled reactor. Okay. Disadvantage is there is a possibility of radioactive contaminations in the turbine mechanism. It means what? The steam, what it will be developed. Just a moment, something goes wrong. Okay. Here, the turbine, just I will go here once again, I'll read. There is a possibility of radioactive contamination in the turbine mechanism should there occur any failure of fuel elements. Therefore, more elaborate safety measures are needed. This added to the cost. It means the steam is generated inside the reactor, so directly it will be feeding to the turbine. There is no heat exchanger here. Heat exchanger is there means this problem can be overcome. What it will be happens if the uh, any contamination in the radioactive material, that it will be hits to the what turbines blades, so that the more elaborate safety is required. Okay, if any failure in of the elements, then it is problem will be occur. Okay, there is a wastage of steam resulting in the lowering of thermal efficiency on part load operation. Since the power density of BWR, boiling water reactor, is nearly half that of PWR, the size of vessel will be considerably large in comparison to that of PWR. Okay. Fourth one, demerit. As boiling of water on the surface of fuel is allowed, the possibility of burnout of fuel is more in case of BWR in comparison that PWR. Okay, PWR, what it will be happens here, the boiling water on the surface of fuel is allowed. Okay, boiling of water on the surface of fuel is allowed. The possibility of burnout of fuel is more in case of BWR. Okay, so possibility of means the fuel consumption will be more in the BWR as compared to the PWR. Okay, a BWR cannot meet a sudden increase in load. This is also one demerit. We cannot change the load, so that sudden increase in load we cannot change. Okay, these are the demerits related to the BWR. Next one is PWR, pressurized water reactor. Okay, the name itself indicates that there will be a pressure in the water. Okay, let us have a figure, line diagram. So okay, both I will explain here. You can see here, pressurized water reactor means, as name it suggests that there will be a pressure in the water. Okay, in this figure, first let us understand the heat exchanger here. Earlier I have discussed about there is boiling water reactor, there is no heat exchanger, but here it is, heat exchanger is present. Okay, in this heat exchanger, the heat it will be exchange will be take place. Okay, it will be carries the coolant, it will be carries the heat, and it will be circulated here, and it will be exchanges here, and it will be given to the steam turbine. And here the fuel is used is enriched uranium. Okay, or another one it is mentioned here that enriched uranium clad with stainless steel or zirconium alloy, and water under pressure is used as both moderator and coolant. And further here, one more very important point to be noted, the uh, water is used under pressure for both moderator and coolant. It functions serves as a moderator and coolant. This type of reactor is designed to prevent the boiling of water coolant in the uranium core. Okay, to circulate the water for pumping. Okay, for pumping, what it is there, uh, they will use here pump. Okay, the speed, the pressure, high pressure it will be applied here. So it will be mentioned that 140 kg per centimeter square. Okay, around the core, so that water in liquid state absorbs heat from the uranium and transfer into secondary loop. So water, what it does, it liquid state absorbs heat from the uranium and transfer it into secondary loop. Secondary loop is comes to the here. Okay, the boiler has a heat exchanger and a steam drum. Here related to the this tank, I will discuss pressurized and surge tank tapped into the pipe loop maintain constant pressure in the water system throughout the load range. An electric heating coil in the pressure boils the water to form steam which is collected in the dome. Okay. Next, this part is I hope clear. Steam it will be comes to the turbines, and once it will be exhaust to the mechanical work it will be done means it will be condensed through this, and again it will be condensate pump that it will be condensed and recirculates it. Okay, it will becomes back. Okay, this is another one circuit pressurized water. So here it will be clearly it is mentioned. Pump and it will be goes to the reactor. Okay, and it will be passes through the hot coolant, and this is the heat exchanger, and water it will be boiled and steam it will be taken out. Coolant rod. Okay, coolant is used here is water. It serves both functions, moderator as well as coolant. Okay, let us have advantages. PWR is relatively compact in size compared with other types. There is a possibility of breeding plutonium by providing a blanket. The reactor has a high power density. Due to use of heat exchanger, contaminant of fusion product is possible. Okay. Any expensive here due to the use of heat exchanger, so contaminant of because fusion product is possible there in heat exchanger, there is a possible of fusion products will be contaminated. Any inexpensive substance, light water can be used as a moderator, come coolant, come reflector. So here the inexpensive substance, because we are used here coolant. If you are comparing with the metal liquid coolant, it will be expensive as compared to the water. So here the it is merits, or you can say the advantages, inexpensive substance. Okay, light water is used. The reactor responds to the supply more power when the load increases. The positive power demands coefficient makes this almost automatic. So this is here possible for to meet the load increases. Disadvantages: the moderators remains under high pressure because we are applying the uh, pressurized water. The name pressurized water you are applying, hence the moderator remains under high pressure. A strong pressure vessel is required. Okay. Expensive cladding materials is required to prevent corrosion. Okay. Some cladding materials are used to avoid the corrosion. So expensive cladding material is required to prevent corrosion. There is a heat loss due to use of heat exchanger. There will, because the next stage heat it will be goes and that it will be exchanged. Earlier case what it was there is no heat exchanger, direct heat it will be goes to the turbine. Okay, so what it will be happen, there will be heat loss in the heat exchanger. In comparison to other types, more elaborate safety devices are required. Okay, With this, I conclude this session. Next class, further classification of reactors I will discuss. Okay, thank you.